So, we today are learning how to find learning how to make box plots. They are sometimes called box plots, and they are sometimes called box and whisker plots. So I put the and whisker in parentheses because I want you guys to know if you're asked to find a box plot, this is what it is. If you're asked to find a box and whisker plot, this is what it is. So I want you guys to have both names for it in your brain. A box and whisker plot is shaped like this. We've got a box in the center. Your box is always going to have a line down the middle. And then we've got a line out each side with a dot at the end. These 1, 2, 3, 4, 5 points represent these 1, 2, 3, 4, 5 pieces of data. So a box plot, instead of showing you a point for every single piece of data, it shows you how far spread out the data is. So the bottom dot, the furthest left dot, that is going to be your minimum. That's your lowest point. Furthest to the right is your maximum. That is your highest point. You've got a minimum and a maximum. Okay. Your median is the number that is in the middle. We've already found medians. So we got to put our numbers in order, and then it is the middle number. So we already knew how to find medians. Minimum and maximum is easy. It's just highest and lowest. And once they're in order, it's super easy. The two new pieces are the lower quartile and the upper quartile. So the lower quartile, which is sometimes also called Q1, is the median of the lower half of your data. So if we split your data in half with that median, and then find the median of just the bottom half. Okay, the upper quartile, same thing, but on the upper side, it is the median of the upper half. Okay. I forgot to fill in this blank right here. Box plots show us the 5-number summary. There are 5 numbers. All right. Box plots show us generally how far data is spread out. So we're going to ask you for 2 different types of range. We might ask you for your normal range, which is going to be your maximum minus, that dash there is meant to be a subtraction sign, your minimum. So you will subtract the highest number minus the lowest. I guess I'm going to write it for the max and min. So highest number minus the lowest number. And then the other thing that we are going to ask you to find is your interquartile range, which inter means between, and then quartile is between your 2 quartiles. So your interquartile range is everything between your lower quartile and your upper quartile. We would want to subtract, so we're going to do upper quartile minus lower quartile. So I'm going to write upper Q minus lower Q. I cannot put the word quartile on that line. Okay. Last thing that I want to talk about is this. What percent of data falls in each of the 4 sections of a box plot? So let's think about a box plot. A box plot is going to cover 100% of your data. Your median chops that in half. How much is in each half? What percent? 50%. I heard a 50 somewhere. Okay. Then your lower quartile and your upper quartile chop each of those in half. Anna, come get this, please. What is half of 50%? 25. Yeah, that's okay. So 25%. No, 25% of data falls in each of the 4 sections of the box plot. 25, 50, 75, $1. So we have 4 sections, but then there's 1, 2, 3, 4, 5 numbers that split us into those 4 sections. All right. We are going to make 2 box plots, and then your assignment, you have 2 you have to make. You have 2 you have to answer some questions about, and then we're going to do a booklet to finish this out for the day, because otherwise I can't show you more because I can't fit more on a sheet of paper, but I feel like you need more practice. So, first problem here is the speed of pitches in a baseball game in miles per hour. Is this data made up? Maybe, I don't remember. We are going to start by putting it in order. So the lowest is 78. When you write, you want to write neatly because you're going to have to be able to look back at this list. So I've got 78, and I've got 80 and 83. And then I think I have 85 and 87. This data has to be made up because it's really just all odd numbers. 91 and 93. And then 95 and 97. Okay, then I like to go through and count 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so min and max, those are easy. I'm going to do them first. What is my minimum number? Minimum. 78. Thank you. Okay, you had me worried there for a second. What's my maximum? 97. Okay. Say those easy ones with your heart. Have a little confidence. Okay, then we're going to go find the median. So for the median, we count from the outside, and this is why you want to write neatly. We've got 1, 2, 3, 4. My median number is this 87. I would put a box, circle, do something with your median. But you want to mark it in some way because you need to know where it is so you can do your quartiles. Okay. Then, here's the tricky part, here's the newer part, is our quartiles. We are going to look only at the lower half of our data. If you have a median that's right in the middle, do not include it. It's not in the lower half or the upper half. So I'm going to look just at the lower half of my data. So just at these 4 numbers, I've got 1, 2. So my median is going to be in between 80 and 83. If my median is in between 2 numbers, sorry, my computer might be dying. It's plugged in though. Okay, she's better now. So we're going to take those 2 numbers, add them together. So 80 plus 83. Hit enter, and then divide by 2. 81.5, which makes sense. 80 and 83 are 3 apart. Half of 3 is 1.5. Then, for the upper quartile, I'm going to do the exact same thing. I am not going to include 87 in the upper half of my data because it's right in the middle. So I'm going to go halfway in between these guys, 91, 97, 93, and 95. It's going to be halfway in between 93 and 95. Halfway in between those two is 94. Okay. Any questions about finding our 5 numbers? Any questions about any of those numbers? So, because it's halfway in between 93 and 95. So I did the 94 in my head because since they're 2 apart, I know 94 is right in between. I could do the exact same thing. 93 plus 95 and then divide by 2. Yeah. Good question. So you can, when you have to do those medians in between 2 numbers, you can do it in your head. You can do it in your calculator. You can just think logically about it. It's the same way anyway. All right. So once you get those 5 numbers, now we're going to put it on our graph. So we put a dot above 78. So I like to go above the graph. So right there, 78, I'm going to put a dot. And then I'm going to put a line at 81.5. So you got to go between 81 and 82, put a vertical line. And then we need to put a line at 87. We need to put a line at 94. And then we need to put a final dot at 97. Okay, grab your okay, then we need to connect those. So the 3 lines in the middle connect into a box. And then you draw a whisker out to each dot. Hey, Dylan, will you grab John? Okay, any questions about that box spot? All right, so you find those 5 numbers and you put them on. That's it. All right, we've got one more that I want to do on the back. So I want you guys to see when we don't have a median right in the middle. So flip this over. We've got one more on the back. And remember, this is an entire page worth of your project. So you got to know how to do these. Okay, the time it takes to travel from work or travel to work in minutes. So we've got an 8, a 10, and a 12. 8, 10, 12. A 14, 15, 17. A 19 and a 20. And then a 22 and a 28.
That's a lot of red lights.
Or just living out of town. That would be miserable if that was traffic. It's not bad if that's like on the highway, but 28 minutes of just straight traffic would be awful. All right, so min and max. Minimum is 8, maximum is 28. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Make sure we had all of them. We have 10 numbers. Go ahead and find your medians, please. I would like for you to count from the outside and find where your median is going to be. Okay, where did you guys end up? Okay, so there's no 16 on the list. What two numbers did you end up between? 15 and 17. I would draw a vertical line right there. So draw a line to chop your data in half. So we need that line so we can do our quartiles here in a second. But right now, to find our median, we could either say what's halfway in between 15 and 17, which is 16, or we could add them together. 15 plus 17 divided by 2, and we would get 16. So I've got a median of 16. Hey, then we are ready to do our lower quartile and our upper quartile. So for our lower quartile, we are just looking at these 5 numbers. So I go 1, 2, 3, and it is this 12 right here. It's an easy median of my lower half. And then for my upper quartile, I'm going to do the same thing with my upper half of my data. So I'm covering up everything that's on the lower half. There's nothing that gets excluded on this one. 1, 2, 3. I get 20 is in the middle. Okay, so we are ready to make our graph now. We can put a dot above 8. We can put lines at 12, 16, and 20. 12, 16, and 20. And then we'll put a dot over here at 28. Connect my box. And then connect my whiskers. Okay, this is one where you can kind of see that your boxes and whiskers, some of them might be really little, some of them might be really big. Let me show you on your assignment. I think one of the ones, there's an example. Yeah, see how like on your box, sometimes the lower quartile is bigger than the upper quartile, or vice versa. So what a box and whisker plot tells you is how far spread out your data is. So if you have a small box or a small whisker, that means there's a lot of data in that section. It's all squished together there. Okay, go ahead and glue in these notes. I'm going to stop this video so I can get it uploaded.